So on the back side of your notes, we are going to rewrite a biconditional statement as a conditional statement and its converse. So here is a biconditional. And the reason I know it's a biconditional are these words, if and only if. So we are going to take out the words if and only if to get it out of biconditional form, and we're going to go back and add the words if and then. So what this is going to look like is, if two angles are congruent, then they are equal in measure. So that is what you're going to write in the conditional statement. So I'll say it again. You get rid of the if and only if, take it out of biconditional form, and you add the words if and then to turn it back into a conditional. If two angles are congruent, then they are equal in measure, which is actually a true statement. So the conditional is true. Now, to write the converse, we're going to take the if-then that we just created, and we're going to do the opposite. We're going to flip it. So based on what we just learned, you're going to say, if two angles are equal in measure, then two angles are congruent. So for the converse, you're going to reverse it. And you're going to say, if two angles are equal in measure, then they are congruent. And that is also true, which is why we had a biconditional to begin with, because both the conditional and the converse were both true. Okay, so I'm going to look at number 10. It says, write the converse of the if-then statement. If the original and the converse are both true, then write a biconditional. If one of them is false, give a counterexample. All right, so we're going to take this if-then and we're going to write the converse. So just to remind you, the converse is Q arrow P. We're going to flip it around. Okay, so I need to flip-flop this if-then. So this is going to sound like this. If two lines intersect to form a right angle, then they are perpendicular. If two lines intersect to form a right angle, then they are perpendicular. Okay, now in order to make a true biconditional, both the original has to be true and the converse has to be true. So we're going to go back and see if they're true. So read the original. If two lines are perpendicular, then they intersect to form a right angle. And just shake your head yes or no whether you think that's true or not. All right, so this is true. Yes, we learned that in chapter 1. If two lines are perpendicular, they form a right angle. Okay, let's read the converse and see if the converse is true. If two lines intersect to form a right angle, then the lines had to have been perpendicular. So if you think about if you're forming a right angle with lines, then yes, they would have to be perpendicular. So this is also true. If both the original is true and the converse is true, we can make a true biconditional. So we don't need a counterexample because we don't need one. We're going to just make a biconditional. All right, here's how you make a biconditional. Go up to the original statement, get rid of the if and the then. Knock out the if and the then, and we're going to add a phrase in the middle of that statement called if and only if. And we're going to base it off of the original if-then statement, not the converse. Okay, so here's what this would sound like. Two lines are perpendicular if and only if they intersect to form a right angle. So some of you might be thinking, why didn't she use IFF? Totally can. I'm just writing it out for now because we're just learning it. But you can also say two lines are perpendicular IFF, if and only if they intersect to form a right angle. And that is called a biconditional because it works both ways. So the symbol for this would be P double arrow Q, and it would show that it works forwards and backwards both ways. So number 11, I'm going to give you 20 seconds to fill in. In order to have a true biconditional, you need two things that are true. First, the original if-then. So the if-then, the original one, which would be P arrow Q, and you also need to know that the converse is true, which would be Q arrow P. If both those are true, then you can make a true biconditional with the words if and only if.